Hi, everybody. Thanks for having me today. I talked to Alex, and turns out people usually present their own stuff in this group, but I just wanted to uh, contribute to this reading group mostly, and this is not my paper, but I just found this interesting, so I thought I'll just talk about it. I've been getting into mechanistic interpretability sort of stuff for a few months now, and have been looking into VLMs a lot. And I was sort of interested in how do these models do image grounding. And just looking for that, I sort of ended up at this paper, and this paper is somewhat interesting because actually, one sec. Yeah, this paper is somewhat interesting because it sort of solves this problem of how to do image corruption in a much more meaningful way. So before this, image corruption was all about adding Gaussian noise to it, but Gaussian noise wasn't very helpful because it would the patterns that you would observe in self-attention and tokens getting importance in the middle layers would sort of get super corrupted. And so they sort of fix that. So down here, what they do is they corrupt the text. So for something like, is the puppy or goat lying on the grass? They can change it to something else, or like even for images, they can sort of change it semantically. So instead of corrupting the dog face, they can turn it into a goat while keeping other aspects similar for the model. One interesting thing is that they build this whole framework, obviously, and through this framework, they're able to find some universal attention heads, and these attention heads are called universal because they cause a huge logic difference in the model's output. And based on that, they study these heads and are able to find that certain heads are responsible for certain things in the model. And we can just dive down. Can you guys hear me? I think I cut out for like
you cut out for a while, yeah.
Yeah, I'm so sorry. Yeah. So I was talking about this notice framework, and the core contribution of this framework is that it um, sort of solved how you can corrupt images in a way that you can do this causal activation patching to study models. That's pretty much most of what that is. So the way they do it is that, like I said, they have this clean input and they'll run this, sort of get their outputs, and then in the corrupt output is mostly like something semantically related. So instead of showing a puppy, you show a goat with other things about the image sort of aligned. And then you can sort of patch different states to see what parts of the model are responsible for the correct output. So that's mostly what they did. And one interesting thing that they actually found out is how models like Lava sort of use the assistant token as just to store all the information. So in this figure, they sort of patched, like let's say for this row, they basically patched the assistant token from the clean run, the dog run, to the goat run at each layer, and then try to see what was the probability difference. So probability difference is that if you patch if you patch the assistant token at, let's say, layer 13, does the probability of the correct answer, which is dog, does it go up or not? So if it goes up, so obviously it's darker. So they tried patching every single token, but they realized that patching the assistant token at the end is probably the most useful one. So which kind of shows that the way self-attention, or at least Lava works, is that it gives a lot of importance to the assistant token when it comes to giving out the actual answer. Same with but this is only for the image. For the text, they saw how the correct if you patch the text in the text, the actual object is much more important than patching anything else. And what else? Yeah, so they did a lot of patching, obviously, and then they talk about, and then they sort of show how Gaussian noise is not a good way to do things. So if you add a bit of noise just to mess up your image for this causal sort of analysis, you don't get any meaningful patterns like you see up here. So they sort of make a case how Gaussian noise is not a good way for image corruption, and we should do what they suggest, this semantic change. You could even use diffusion models for the same, even that works surprisingly. And then they sort of dive down into something called this universal heads. So they were really trying to study how attention works, like how self-attention works, how cross-attention works. And yeah, so based on this, so they find a bunch of universal attention heads, and they call something a universal attention head if it consistently has a larger difference of 2 standard deviations above their standard average that they calculated. And surprisingly, Lava has a lot of universal heads than Blip. Not sure why, something to do with cross attention and self attention, I guess. But lava also has a lot of multimodal heads because of lava does early fusion and blip does not. Um, then they sort of study these 7, 8 heads and this 2, 3 heads over here to see what are the functions of these heads, like exactly when it comes to image and text fusion, because they're multimodal heads. And they sort of see something interesting, how like cross attention heads in blip, they're able to do detection. They can even map certain parts of the image to text patches, like this would be called dog, this would be called mouth. Even sometimes, like, they can even patch things that are not in the prompt. Like, since this person looks kind of pissed, they'll map this part as anger. There's some heads that also do object suppression. So, like, yeah, I'm confused how it works, but they say that these certain heads are able to sort of give attention away from things that matter. So like they pay attention to everything but the dog, or like everything but the man. So that's interesting. But in lava, they really couldn't find any heads that did sort of this patching of image patches to text tokens or anything that did this object suppression. But they did find outlier suppression heads. So an outlier suppression heads is they basically do cleanup. Like they would just divert attention away from other patches. I'm also not really sure how it works, but that's all I could figure out from this paper. That's pretty much it. I mean, there's lots and lots of, there's decent amount of work in references, talk about data sets, and they talk about how you can do this corruption with stable diffusion and how it's still workable. Yeah, that's pretty much it. Yeah, I was, take a look. Yeah, I was mostly interested in how they say that, here they talk about how lava has these multimodal heads, but none of them are actually responsible for linking image patches to text tokens. But lava does do a lot of visual grounding, and there's benchmarks that sort of prove that. So I'm not really sure. I mean, they were not able to capture how image grounding happens in lava, but it clearly does happen. So maybe image grounding is a very distributed phenomena that is like scattered around multiple layers and multiple attention heads. So what do you all think?
Does blip have cross attention, or is it only self attention?
So blip has cross attention and self attention as well. Lava only has self attention.
Oh, okay.
Any other questions?
Have you seen any of those other data sets they mention in limitation section, like Shape World and Clever? Have you seen anyone using that? I think there's also one called Deep Fashion.
Well, I have seen lots of paper that use these data sets, but not on this framework.
Not Notice.
Yeah, not on Notice. Notice is very early, I think. This paper was out in like this Feb.
Okay, yeah.
Yeah. Those are good data sets to sort of run by this framework. The only limitation is to make those some in the image pairs, you know. It's a bit of a hassle. Guess we could end if nobody has any questions.
Yeah, if nobody's saying anything, I guess we can just end it here.
And this is a pretty cool paper. Yeah, I enjoyed reading it.
Thank you. It's just my first time presenting to a bunch of people, so didn't have much prepared, I guess.
You're a PhD student?
I just started like 2 weeks ago.
Oh, nice. For CS?
Yes.
Oh, nice. So I guess we're done then.
Yeah. Oh, does anyone have any idea for the next reading group? I have a paper in mind, but we could do something else if people want. Also, yeah, if someone else wants to like read and present a paper someday, they can do that too.
Sounds good. I'll do it when I find a paper I like.
Yeah, but apart from that, I guess we can leave it. Yeah,
Do we need to
people have-
record
yes.
still when we're deciding who's doing the next reading group?
Sorry, can you repeat that?
The recorder's still on while we're trying to decide the next thing to read.
Yeah, I should just stop it, right? Wait a moment.